This is part two. Sorry, this is part 2 of our lesson on vector addition and subtraction. So what we are going to do is we are going to try a question and we are going to answer it 3 different ways. We are going to try solving it by drawing. We are going to try solving it using sine and cosine law. And we're going to try solving it using what we call components, where we're just using right angle triangles, which is the physics way of doing it. So we are going to start with drawing. I will say at the start that anytime you are trying to solve a question by drawing, you have to be very, very accurate. So your drawings, everything has to be measured exactly to scale, right? Your angles, your lengths, everything. So you have to be very careful and very precise if this is how you want to do the question. All right, so our question here says determine A plus B, so vector A plus vector B, if A in those little brackets, so that's the magnitude or the length of A is 5.2 centimeters, the magnitude of B is 7.2 centimeters, and the angle between the 2 vectors is 40 degrees. So I am going to start by drawing the information that they gave me in the question. So they said that A is 5.2 centimeters, B is 7.2 centimeters, and the angle between them is 40 degrees. So I'm going to take my ruler and I'm going to see if I can actually measure them to scale. I think I should be able to. If I couldn't, then I would try to maybe do millimeters instead of centimeters so that I can at least still do 5.2 and 7.2, but I think I might be able to fit the centimeters on here. I tried to plan it out so that I could. Okay, so I'm going to come down here near the bottom. I'm going to try to give myself some space. I'm going to try drawing vector A, and then we're going to measure 40 degrees and then try to draw vector B. Now vector B is longer, so that's why I'm trying to start down near the bottom of the page. And as I said, if we're going to do this by drawing, we need to try to be as accurate as possible. I would recommend using pencil, so if you make a mistake, you can erase it, but the pencil doesn't show up very well on the camera. So I'm going to do my best not to make a mistake. All right, so we're doing 5.2 centimeters. So I'm going to measure 5.2 centimeters. I'm trying to be very precise. At least as precise as I can be. And that is vector A. Okay, vector A and vector B meet at 40 degrees. So I need to figure out where 40 degrees would be. So I'm going to take the center of my protractor, put it at the the tail of my vector. A lot of glare from my light here. I'm going to try to measure 40 degrees. All right, so that's 10, 20, 30, 40. Just put a little tiny tick mark there as guidance. And then I need to measure 7.2 centimeters. And you need to be as accurate as you can. So I'm going to try to line up the end of my vector through the little tick mark that I just made. And I have to leave a little bit of clearance because the marker is thick and it doesn't line up exactly with the ruler. Okay. Here's vector B. So I have vector A, vector B, and this is 40. Now it is 40.00. You could just write 40 degrees. Okay. So when I want to add these together, right, I can't just connect these 2 parts because they're both heads. In order to add vectors together, you have to go head to tail. So I would start with vector A. Here's vector A. And then what I need to do is line up vector B so that it goes here instead of here. It needs to line up here. And in order to do that, I either need to do a little bit of calculating or I need to draw in some extra lines. So we'll try it with the draw the extra lines, and then we'll talk about the calculating part. So what I need to do is draw B over here. So I need to slide this angle over, which means I'm going to have to measure out that 40 degrees again. So I'm going to just put a little extension here so that I have something to measure my angle off of. I'm just putting a little bit of an extension there. You probably can't really see it with the pencil. It's just there so that it continued the line so that I can do the part with my protractor. There's a lot of glare. Did I mention that for my overhead light? All right, so there's 1, 2, 3. There's 40 degrees again. So I am now going to draw at 7.2 centimeters. Sorry, and it's slow going because I'm trying to be very accurate. There is 7.2. Okay, so that means this little angle out here now is 40 degrees. What would that make that angle on the inside? Well, if this is a straight line and this little angle on the outside over here is 40 degrees, then this would be 180 minus 40 degrees, or 140 degrees. Also, this line here and this line here, if I have drawn them correctly, should be parallel. And two parallel lines, if they may form a C pattern, these two angles add to 180 degrees. Okay, so from here, I need to draw in my resultant vector, which should go from the beginning of A to the end of B. Oh, I didn't mark that that was B. So this is my tail. The head is going to be here at B, and then there is A plus B. Okay, so because I drew it and I tried to be really careful in how I drew it, I just need to measure the angle that it makes now with A, so this angle here, and I need to measure the length of the vector. Now, if I didn't draw this very accurately, I am not going to get the right answer. It's going to be a little bit off, but let's hope I did a fairly decent job. Let's hope you did a fairly decent job. All right, I'm going to measure my vector. All right, it looks like 11.7 if I go to the end of where my little black vector there is. I got 11.7. So I'm going to say that A plus B is 11.7 centimeters. And then I need a direction, so I'm going to use my protractor and I'm going to try to measure this angle in here. The one I'm not so sure about here. All right, we've got 10, 20, 1, 2, ooh, I think that's 24, maybe. So I got 24 degrees, and I need to state that this is 24 degrees to vector A so that I know what I measured it from. And we always measure vectors when they are tail to tail. Right? And then when we add them, we put them head to tail. But when we're measuring them, we always measure when they're tail to tail, which is why I'm doing it with angle A and not angle B. So based on how I drew it, I got that the length or the magnitude is 11.7 and the direction was 24 degrees with vector A. So we are going to try it again using some calculations. So I will see you in the next video to take a look at how to do it with sine and cosine law.